the graph of f of x equals, okay, it's a cubic function, x cubed, take away 2x squared minus 5x plus 6 is shown in the xy plane above. How many distinct zeros does the function f have? In other words, remember the expression zeros means how many crossing points exist between the curve f and the horizontal line y equals 0. Y equals 0 is actually this, right? The x-axis is the same as the horizontal line y equals 0. So how many crossing points do you see there? Easy, right? Yeah. Here is one, a second, and a third. So the answer to this question is there are 3 distinct zeros for the function f. What are their values actually? Okay, if we assume that each of the boxes in the quadricle corresponds, each division of the line is 1 unit, you could say that this is for 1, 3, and -2, perhaps, okay? But here is the concept that you need to catch, okay? How many distinct zeros, how many x-intercepts? You can read this zero, this word zero, also as x-intercepts. Well, there is a second part to this question. The same graph, the question says, if k is a constant such as f of x equals k has one solution, which of the following could be the value of k? How do we interpret this question? Remember what I told you? If they tell you that there is a graph of a function and they tell you solve what is the solution for f of x equals k, f of x equals k means find the number of intersections, okay? The number of intersections between the function f and the line y equals k. But since they already tell you that for a certain value of k, this problem has only one solution, it means that the position of k must be such that when you count the intersection points between the horizontal line y equal k and the curve, there is only one possible intersection. Example, imagine that this is one possibility. If I have this as my y equal k, this is my y equal k horizontal line, clearly this line intersected with the curve of function f would only have this solution, right? This would be the only intersection point. Another possibility is, for example, here. This is another example of another line y equal k. When I solve the problem f of x equals k, this will also yield me just one solution, this. This will be the crossing point between these two lines. I will find the value of x for this intersection point by solving this equation, f of x equals k. So, since they give you 4 alternatives, which of the 4 alternatives looks like the green or the blue line, would you say? Let's take a look at one at a time. Could it be y equal to -3 or f of x equal to -3? Where is -3? Take a look. If this is 2, clearly this is 1, and this is -1, and this is -2, and this is -3 here. So does a line, passing on that vertical position intercept the curve f in just one place? That would be the meaning of saying one solution. No, it intersects the curve in 3 different places. So we can cross out this one. What about k equal 1? Is that possible? K equal 1 is over here. Again, we have 3 solutions, not just one. Cross out this one. What about k equal 5? 5 is here. Take a look at this. This is the passing point for the line. Again, we see 3 different solutions, not just one. So we have already crossed out 3 options. The correct one must be the last. 9. And we can verify that that is actually correct. Take a look. Why? Because simply like this, this is 4. So this is 5, 6, 7, 8, 9. Clearly, if this is the position of 9, a line crossing the vertical axis in that position, when you solve f of x equals 9, you will have only this intersection point. So that is why this is the correct answer choice. Okay,